Okay, welcome to lesson 4 of this first unit in grade 11 university. So we're going to start talking about the base functions today, some functions that we're going to study specifically in this course, in this unit. And there'll be a number of more base functions that we'll study as we go on into exponential equations, trigonometric equations. But in this first unit, we're just going to look at 4. And the warm-up here is just the intention here is so that you understand a couple small definitions a small definition for the second one, and then for the first one, it's to understand what this function might be. And so if you want to read those, and you can just think about them. So this question is saying we call this the absolute value of -3 gives you 3, -5 gives you 5, 3 gives you 3, and the lines give you 5, 5 gives you 5. What happens is, we ask the question, what does this look like? And this is going to be a question that we're going to explore today. And so if you want to plot these points, you might get an idea of what's happening. So we've got inputs, which are the x values, and then the outputs, so -3, -5, 3, and 5 are the inputs that go into this function. And then the outputs are 3, 5, 3, 5. The second question, so I'm not going to answer that question because we'll talk about it today. But if you want to start looking at what that looks like, then you can do that. Second question, what is the domain and range of this? And so you can see what that might be. And so this is really a review of the last day. The domain is all real numbers. X goes on forever in both directions. And then the range is all real numbers but greater than 0. Notice how we don't say equal to 0. The function actually goes smaller and smaller and smaller and approaches this like what we call a horizontal line. The line that it approaches is called a horizontal asymptote. The line y equals 0 in this case is called a horizontal asymptote. And we're going to see some more asymptotes today. Okay. Use Desmos to investigate the 4 following functions. So what you're going to do is just one at a time, go on the computer, and you can actually start to take a look at what these functions actually look like. So first function, we call this the absolute value, the square root, and we call this one the reciprocal, and this is the x squared graph. So in your notes, you can actually do this with a table of values as well, and then start to plug in the table of values, and then we'll take some notes on each function. So if you want to plug all of these into Desmos, remember to plug it into Desmos. So we'll just show you x squared. We just go to Desmos and we can write f of x equals x squared. The keypad here gives you some of those functions, but you can just press the shift 6 will give you the hat and then a 2. And so you can see this is a popular function that we looked at last year, and it is the quadratic. If you click on the settings, so again, it's just playing around with Desmos. If you click on the settings, you can convert it to a table as long as it's a function, and it'll give you a table of values. So you can see, if we sub something in, if we sub in 3, we get 9, and that's our table of values. Okay. And so this is our parabola. That's our first function. And if we go back to the note, we just fill out the table of values. So what's happening here is we're plugging in x in for x squared, and so we're just squaring all the inputs. And the graph looks like that. That's right from Desmos. Notice the table of values, it'll actually give you the points. So if you plot those points on the little graph given, then you just draw a parabola through them. Some notes, we square the inputs to get the output. It's the x squared function, the quadratic function. It's a U-shape. We call that a U-shape, or we call it a parabola. It has a vertex. We call this the vertex. And it has a step pattern. So over 1, up 1, over 1, up 3, over 1, up 5. If you remember from grade 10, that was actually a helpful way to graph this. So to know that it's correct. The domain's all real numbers because x can be anything. and the range is greater than or equal to 0. So it can be 0 and higher. So this is just this function here, not doing anything to it. It's just x squared. Okay. So the next one we'll look at is the absolute value function. And so if we go to Desmos, we just change x squared into the absolute value. Just delete what we had. And this is what we get. And so this might be what you guessed we would get. And so what the absolute value does is it takes the inputs and it just returns a positive number. So you can see that here. So any negative number like negative 100 would give positive 100. We're not going to see that on the graph because it's way out this way. But I guess if we scrolled out enough, you could see it. Okay. And so that's the absolute value function. So going back to the note, we can plug in the inputs. We just take the positive numbers of the input and we get the output. So absolute value of -2 is 2. Plot those points on the graph. We get something like this. It goes on forever in both directions. You can draw little arrows on the graphs. It's just some of this stuff is challenging to do on PowerPoint, so I sometimes don't do it. So you can draw little arrows on the graph to say that you're going forever. In general, when you see it go off the grid, it means it goes forever. Okay. This is called the absolute value function. Each input is made positive for the output, so we take the absolute value of every input. There's a lot of similar properties to the quadratic. You're going to see the domain and range are very similar. We just have a V shape instead of a U shape. The step pattern, we don't really look at the step pattern. It's not the same thing. It's just over 1 up 1 over 1 up 1 over 1 up 1. Instead of the vertex, we don't call it a vertex for the absolute value. We call it a cusp. And so that's a word that's going to come up again in calculus. It's very important for derivatives in calculus. The domain's all real numbers, just like the parabola, and the range is just like the parabola is greater than or equal to 0, just like the quadratic. Okay. Next one we're going to look at is the square root graph, and so we go over to Desmos and we plot the square root graph, and so we've got a little symbol on the keypad to take the square root. We don't want square root of absolute value, although that was really interesting. We're just going to take the square root. And we're not going to square root all of these numbers here. And you'll notice in the just reconvert that to a table. You'll notice that in the note, we'll talk about it, but doing things like 2 isn't really helpful. So we do things like 4 and 9. So numbers that we can actually take the square root of. We notice that -2 and -1 are undefined because you can't take the square root of a negative. And 2 will give you a number, but it's not a rational number. It's not a nice number. Okay. And so we go back to the note and we say, well, -1's undefined, 0, 0, 1's 1, 2 is √2, which we don't really use because it's not a nice point. So it's really hard to graph that. And so we just don't use it. So instead of using that, we actually use 4 and 9, which we can square root nicely. When we plot those on the grid, we get something that looks like this, and it goes forever in that direction because you can keep taking the square root of positive numbers. Okay. A couple notes, it's called the square root function. You put in convenient inputs. That's the reason why we use 4 and 9, because just numbers are easy to square root. It's a half parabola, so it is actually very similar. Like as you suspect that x squared is very similar to root x, it is very similar. This is actually half of the parabola. Yeah. So I mean, you could see the step pattern over 1 up 1, over 1 up 3, over 1 up 5. It still works, although that gets a little confusing to draw it that way. Domain is x greater than or equal to 0. And the range is greater than or equal to 0. It's all real numbers. We can get all real numbers. Some of them just might not be nice. So, okay. And the last one we look at is 1 over x, which is probably the hardest one to understand. And so if we just type 1 divided by x, we get something that looks like this. So we're just going to re-put like 3 and 4 in here so you can see what happens. Notice how 0 is undefined, and the graph just gets smaller and smaller, and it gets bigger and bigger as you get to 0. And what we call these is asymptotes, just like we did in the warm-up. These are lines that the function approaches, but doesn't cross. And that's not always the case, but that they don't cross them. But in this case, for the 1 over x graph, you'll never cross it. So you can be comfortable going forever up and then forever approaching 0. Okay. So if we go back to the note, what we're actually doing to the inputs is we're doing 1 over them. So really what we're doing is the reciprocal of all the inputs. So we get -1 and -1, -1/4. We use that kind of thing just to get some shape towards the x-axis or the y-axis. 0 is undefined. We can't plug in 0. That's why we do use these fractions. And when we get into graphing them with transformations, we'll use -1/2 and 1/2, and we'll use +2. It's just showing that, like, whatever the input is. So these aren't the key points we're going to end up using in this course. But whatever the input is, you just take the reciprocal, and that gives you the output, and that gives you the base graph. And so that's what it looks like. And so just plugging in more allows you a little bit more knowledge on what it looks like. And so you might wonder, oh, I didn't know, like I got these points, but I didn't know how to connect them. Like I thought you'd connect them this way. And that's partly the reason why we do it with the graphing calculator, so it can show you. But if you plug in more numbers, like it will give you more evidence as to what the graph's going to look like. And you only have to do it once, and then you really understand what it is. Okay? -1 and 1. 1 and 1, the reciprocal of 1 is 1. So we didn't do that point, but you can see that point on the graph. So a couple notes. This is called the reciprocal function. So we take the reciprocal of the input to get the output. Notice we don't take the negative reciprocal. Reciprocal gets put in with negative reciprocal in grade 9, and then students can't really separate them. We're only taking the reciprocal. Function approaches horizontal and vertical asymptotes. So these lines here, the y-axis and the x-axis, so y equals 0 and x equals 0, are vertical and horizontal asymptotes. The domain, it's much easier actually to tell what it can't be. And so that's what we do with the restriction. So we say x can be all real numbers, but it can't be 0. It can be anything other than 0. So that's how we write it. That's the first time we've seen a domain written that way. And the range is the exact same thing. So it can be all real numbers, but not 0. Okay? And so there's some practice questions just to get familiar with the base functions. That's all we're doing today.